All right, hello everyone. So today is Ray's math class, and this time I'm bringing you this latest the methods exam 2 extended response questions. So first thing first, please forgive my retype the question because I have to grab the source from the internet without like the actual papers. And let's start it. As this is the extended response in the exam 2, we can have the test, the technology to help us, and also please prepare it next to you. All right, a manufacturer produces tennis ball. The diameter of the tennis ball is a normally distributed random variable d, which has a mean of 6.7 centimeter and a standard deviation of 0.1 centimeter. So first thing first, on your draft paper, you can just write the variable d is the mean 6.7 and the variance is 0.1 square. The first one, find out the probability that the d is greater than 6.8, correct to 4 decimal places. This kind of questions versus one mark, just open your CAS, menu, probability, distribution, and the normal PDF. All right, after you type in the required things, and then you can work it out. The answer is 0.158655, blah, blah, blah. But we need correct 4 decimal places. So round it to 1587. And that is the answer. All right, that is the answer. Next, find the minimum diameter of a tennis ball that is larger than 90% of all tennis balls produced. Give your answer in centimeters, correct to 2 decimal places. Let's just use a diagram to represent. Now, we would have a bell-shaped normal distribution graph. The symmetry line is the mean, which is 6.7. And we are looking for on somewhere the value. And the probability would be 90%, which is 0.9, right? So the function we need is the inverse normal distribution, all right? Inverse normal distribution. And please, again, remind yourself that the inverse normal distribution function can only looking for the value from negative infinite goes to your required value. Never be based on this value and goes to the infinite. After we type in, it would be 0.9 as the area, 6.7 as the mean, and 0.1 as the standard deviation. Click it, and this time we just need to correct 2 decimal places. So it will be the 6.83 centimeter. So for this kind of question, it is no harm to just write down 2 letters to represent the unit rather than not ignore it. Okay? And please remember that every question we would have different requirements. So even if the A part requires 4 decimal places, it doesn't mean in the B part we will also correct 4 decimal places. Always read the questions before you actually start it. Tennis balls are packed and sold in cylindrical containers. A tennis ball can fit through the opening at the top of the container if its diameter is smaller than 6.95 centimeter. Find the probability that a randomly selected tennis ball can fit through the opening at the top of the container. Give your answer correct to 4 decimal places. So now we are looking for the probability that the D is less than 6.95. All right, what's the mean? Again, 6.7. What is the standard deviation? 0.1. And this time we would have no lower boundary. All right, no lower bound. Just use the negative infinite. All right, negative infinite. And then we would find out the answer 0.9938. Now we turn it back to 4 decimal places. D. In a random selection of 4 tennis balls, find the probability that at least 3 balls can fit through the opening at the top of the container. Give your answer correct to 4 decimal places. Look, if you have a ball that is too large, which means the diameter is definitely larger than the pipe diameter, all right? And then the ball would not going through, it just stuck at the opening. Then we have to make sure that every ball we check it and test it. Can it fit through or not fit through? So this time, the distribution goes to a binomial distribution. Binomial distribution only has two outcomes, yes or no, success or fail. And every trial, the probability would be same, okay? So now your variable, just say using another variable, would be a binomial distribution. The trial number would be 4, all right? And the success probability would be 0.9938, which is we just adopted from last question. Because only if your diameter less than that value, the balls can go through. Otherwise, stuck it, all right? And then we can use either way the binomial PDF or binomial CDF. Why? Because binomial distribution is a discrete random variable distribution. If we're looking for the t probability of the t larger than 3, it is actually lower or smaller or equal to the upper bound, which is the maximum number of the trial number, 4. So either way, you can use the binomial CDF, directly looking for the lower bound of 3 and upper bound of 4. Sorry. Or you can just looking for binomial PDF, t equal to 3 and t equal to 4, and looking for the sum. They would have the same answer, right? They would have the same answer. And after that, you can find out the answer is 9998. 9998. That's it. All right. Next question. A tennis ball is classed as grade A if its diameter is between 6.54 and 6.68. Otherwise, it is classed as grade B. So either way, too large or too small, then you can only list it as grade A. Given that, look, once you see the word given, the first thing comes to your mind would be, okay, this is a conditional probability. Given that a tennis ball can fit through the opening at the top of the container, find the probability that it is classed as grade A. Give your answer correct to 4 decimal places, all right? So we are looking for what is the probability here? Look, what is the condition? The tennis ball can fit through the opening. So the condition would be the diameter is less than 6.95. That is the condition the ball can go through, right? And then the question is looking for the grade A, which means that is between 6.68 and 6.54. And you're looking for the probability for this, all right? And then the intersection is definitely be the grade A, so 6.54 less or equal to D, less or equal to 6.68. And the passing through, the ball can passing through probability would be the 0.9937903. The reason I use more than 4 decimal places is for avoid the error to make them cause the mistake. Because if the question requires 4 decimal places and we adopt round up to the 4 decimal places answer from the previous question, we may have a tiny difference comparing with we use more correctness, like 5 decimal places or more. So it is no harm to use more decimal places during the calculations. All right. And after that, we can work it out. The answer is 0.8960. All right, 0.8960. If you previously still consistently use 4 decimal places, maybe you could have 8959, or you could still have 8960. But just try to minimize this risk. Okay, always try to minimize the error. Now we jump to that. The manufacturer would like to improve the processes to ensure that more than 99% of all tennis balls produced are classed as grade A. Assuming that the mean diameter of the tennis balls remains the same, find the required standard deviation of the diameter in the centimeters, correct to 2 decimal places. Now, this question is looking for, we have to maintain, right? The mean of the diameter of the tennis ball is the same. But now we would try to get a new standard deviation. Then we can make sure that with the same boundary, more than 99% are in this interval. So the graph would still be 6.54, 6.68, and the mean is 6.7. Nothing changed, but now I need this probability is 99% and more, okay? Then we would try to find out a way, all right? If it is 99% between these two values, then the probability that less than 6.54 would be 0.005. The reason it is not 0.01 is the shape or the bell shape is a symmetrical shape. So left part is exactly same as the right part. Together, they are 1%. So each part would be 0.005. All right? And as we cannot find out the standard deviation directly, we would try to find out a way by the standard normal distribution. So we would try to find out over the standard normal distribution, the mean is zero, standard deviation is 1. And on here, we can create a 99%, and here is 0.05. What is the lower boundary now? All right, what is the lower boundary now? And then after you use your calculator to find out the inverse, all right, the inverse normal distribution, you can type in negative, you can type in the area is 0.05, mean is 0, and standard deviation is 1. You could find out the corresponding answer would be negative 2.5758. And I believe that number is enough because we just need to correct to 2 decimal places. As long as we more than two decimal places during the calculation, it will be good. All right, it will be good. And by the rule, if we convert a general normal distribution to the standard normal distribution, we have to use the score minus the mean out of the standard deviation, and that is equal to the corresponding standard normal distribution score. In here, the score, the normal distribution score will be the 6.54, and minus the corresponding mean, that's 6.7. Looking for the standard deviation, and that has to be less or equal to the negative 2.5758, because we need the middle area more than 99%. Then the two-side area is less than 1%, right? Less than 1%. Then left boundary would go to more left, and the right boundary would go to more right. After you solve this inequality, you can work it out that the standard deviation is less or equal to the 0.062, and the rest number, we don't have to do it because we just need 2 decimal places. So the maximum would be the 0.06. That's it, 0.06. All right, part G. An inspector takes a random sample of 32 tennis balls from the manufacturer and determines a confidence interval for the population proportion of the grade A balls produced. The confidence interval is given by this. Lower bound, upper bound. Correct to 4 decimal places. Find the level of confidence interval that the population proportion of the grade A ball is within its interval as percentage correct to the nearest integer. Now, for the population proportions, we would have the formula is p hat, the confidence interval is p hat minus the margin error, which is the corresponding z-score out of square root p hat times 1 minus p hat out of the trial number, the sample number, right? And the upper bound is p hat plus the score, standard normal distribution score, p hat 1 times 1 minus p hat out of the sample number. So in here, we can see these lower bound and upper bound plus each other is double of the p hat. So 2 p hat would be the 0.7382 plus 0.9493. Directly, you can work it out. The p hat is 0.84375. Do not round to 4 decimal places during the question. Only round it up at the end of the question. And then, after we find out the p hat, for the z-score, for the margin error part, right? For the margin error part, we would have the p hat plus the z value times the p hat 1 minus the p hat out of the 32. Now, p hat, you know it. Sample number, you know it. And then the lower, and here, we can use either way the lower bound, upper bound. Doesn't matter, right? If you try the lower bound, you would have exactly the same thing. And then you should equal to the 0.9493. Although it looks bizarre, but as p hat is known, it is actually a simple and easy linear equation. As I mentioned, easy. I do not want you to calculate by hand. You have calculator, use the technology. After you solve the problem, the z value is 1.664 and 435, such things. For the first glance, and the first thing comes to your mind, it would be 90% confidence interval, because in the book, we practice for 90% confidence interval, for the 95 and for the 99% confidence interval, what is the corresponding z-score? All right, but you could also use the inverse normal distribution. Use the inverse normal distribution from, use normal CDF from the negative infinite goes to this score, 1.64443. And then standard mean is 0, standard deviation is 1. And you can find out the answer is round up to 0.9500. So that is 95%. However, if you sketch it, it goes to this value, and the complete area is 0.95, which means the tiny bit is 0.05, which is 5%. And we are looking for the confidence interval. So it would be from negative 644 to go to the positive 644. And you have to subtract another 95% from the 95%. Then it corresponded to the 90%. 90% confidence interval is the answer of the question. All right, last page. A tennis ball coaches uses both grade A and grade B balls. The serving speed in meters per second of a grade A ball is continuous random variable. V with the probability density function. Now we have the probability density function. It looks weird. It looks some prenumerals expressions. However, pi is a constant number. So it's still a number. Find the probability that serving speed of the grade A ball exceeds 50%, that's 50 meters per second. Gave your answer correct to 4 decimal places. Now, think about one thing. What is pi? You can give me like around 3.14, 3.1415, blah, blah, blah. But you know the estimate, right? If you have a 3.14 such thing, then square it would be definitely more than 9. Times 3, more than 27, plus 30, more than 57. Then here, 50 meters, that is the lower bound. So you are looking for from 50 meters per second goes to the upper bound, 3 pi squared plus 30. And over this, FV dV, doing the definite integral. So use your CAS, find our answer, and round to final decimal places, 0.1345. Next, find the exact mean serving speed, all right? If we're looking for the exact, we cannot round out. So if your CAS setup, let's floating the decimal places, you better correct to the exact value. In the meters per second, now for the mean of a PDF, we need to find out from over the given domain, the variable times the function and dv. All right, just use calculator to do it. After you work it out, the answer, it would be the 3 pi square and the plus 12 meters per second. All right, meters per second. Now, next question. The serving speed of the B is given by continuous random variable W with the probability density function, the PDF GW. Then we have a transformation maps the group from the F to the function G, where the GW is equal to the A times function W out of B. All right. If the mean serving speed of a grade B ball is this, all right, 2 pi squared plus 8 meters per second, find the values of A and B. So now, the old mean, we just work it out, is 3 pi squared plus 12. The new mean is 2 pi squared plus 8. Though looks no connection, but after you factorizing, 3 pi squared plus 4, 2 pi squared plus 4. You can see the mean becomes 2/3 from before to now. All right. So what we do is the dilation factor of 2/3 from what? We change the X value, the horizontal values, right? So we're doing the dilation against the vertical axis. All right, we're doing it vertical axis. So the B is equal to 2/3 because once we're doing the dilations, we're using the variable divided by the dilation factor. All right, so here we divided by B and the dilation factor is 2/3, then B is 2/3. And then as the function haven't changed, we have to make sure that we maintain the same. A is equal to the reciprocal of the B, which is A equal to 3/2. This is the final answer, right? Thanks for everyone to watch the video. If you're interested about our tuition program, please contact our admin via the different social network. And also, if you need the complete notes and questions material for this time, please direct the message about our kindly admin and get one. Have a good night and see you next time.